We're on 76. In the figure below, AB, line AB is tangent to circle O at point A. Fair enough? Point A. Secant BD intersects circle O at points C and D. Right, this is secant BD. Secant BD. And secant just means it intersects the point at 2 points. It's not tangent. A tangent intersects a circle at exactly 1 point. All right, secant BD intersects a circle at points C and D. Measure of arc AC is equal to 70 degrees. So the measure of arc AC, this is 70 degrees, okay. And the measure of arc CD is equal to 110 degrees. That's equal to 110 degrees. So what do they want us to figure out? What is the measure of ABC? So what is ABC? So what is this angle? That's what they want us to figure out. They want us to figure out this. Right here. That angle. Let's see what we can do here. So there's a couple of ways to think about it. Well, there's one way. Well, if you look at this is 70, this is 110, right? So if you add them, this whole arc going for all the way around, that's actually what? It's 70 plus 110. That's 180 degrees. So it's actually perfectly halfway around the circle. So actually, from A to D is actually a diameter of the circle. How do I know that? Because it goes all the way around the circle. It's 180 degrees. The arc length is 180 degrees. So we can let me draw a diameter line. I don't know if this thing is drawn to scale. So A to D is actually a diameter of the circle, and we know that because that's 180 degrees, the combined arc length right there. And we know that this line is tangent at point A. This line is tangent at point A. So that has to be a right angle, right? When you're tangent at point A, that means you're tangent to the radius at that point. Fair enough. So now let's see what we can figure out. We know that this arc length is 70. Is there any way to figure out what this angle right here is? Because if we know this angle, we know this is 90, then we could figure out that angle. And this is something that you should just learn about what do you call them? Inscribed angles in a circle. This is an inscribed angle because the vertex touches on one of the sides of the circle. So an inscribed angle, and this is just something good to memorize, and you could play around with it to get a little bit more intuition about it, is equal to half of the arc length that it intersects. So this inscribed angle intersects an arc length of 70 degrees, right? So this is 35 degrees. It's 35 degrees. And that's just something good to know, that this is going to be half of whatever this arc length is, right? Now we can figure out x, because x plus 35 plus 90 is equal to 180. So let's see, you get x plus 35 is equal to 90. X is equal to what? X is equal to 90 minus 35 is 55, which is choice C. Now there's another way you can do this, and this is another interesting thing about lines that intersect in circles, is that this angle measure right here, if it's sitting outside of the circle, and I think there might be ones where it's sitting inside the circle later on, but if it's sitting outside of the circle, it's equal to 1/2 the difference of the arc measures that it intersects. So example, it intersects this arc measure of 70, and it also has this arc measure right here. Right? When it hits the circle and it intersects at 70 degrees, and when it exits the circle, it has this arc measure. This arc measure, we already figured out, is 180 degrees, because that's 180 degrees. So you know that this angle right here, you can say that x is equal to 1/2 the difference of these two arc measures. And that we can do that because x is outside of the circle. If x was inside the circle, then x would be 1/2 the sum of the two measures. So what's the difference? It's 180 minus 70. So that's equal to 1/2 times 110. So that is equal to 55 again. So it's nice to see that math works correctly no matter how you do the problem. Problem 77. In the circle shown below, the measure of arc PR is 140 degrees, sure enough. The measure of angle RPQ is 50 degrees. Okay, that's 50 degrees. What is the measure of arc PQ? what is this arc right there? So we could use what we learned in the last problem. 50 degrees is an inscribed angle, right? This is an inscribed angle. So it's going to be half of the arc length measured in degrees, or arc angle, I guess you could say, of the arc that it intercepts. So if this is 50, then this arc measure is going to be 100 degrees, right? So what we're trying to figure out, this arc measure right here, it's whatever you really have left over, right? A whole circle has three, let's call this x. So we know that x plus 100 plus 140, well, that goes all the way around the circle, right? That's going to be equal to 360 degrees. So you have x plus 240 is equal to 360 degrees. Subtract 240 from both sides. You get x is equal to 120 degrees. Choice D. Problem 78. The vertices of triangle ABC are, okay, A is 2, 1, B is 3, 4, and C is 1, 3. If triangle ABC is translated 1 unit down, so 1 unit down means that we're subtracting 1 from the y's, right? And 3 units to the left, so that means you're subtracting 3 from the x's. To create triangle DEF, what are the coordinates of the vertices of DEF? So let's see. We have A was 2, 1, 2, 1, and that's going to be translated to, let me write it neater. A is 2, 1, and that's going to be translated to point D. And what do they say? 1 unit down. 1 unit down means the y decreases by 1. So the y coordinate is going to be, decrease that by 1, you get 0. And 3 units to the left, so that means you decrease the x coordinate by 3. So 2 minus 3 is negative 1. Negative 1. Actually, just looking at the choices, we're already done. Right? D is the only choice that had a negative 1, 0. But let's look at the other ones. Maybe somehow they changed the lettering or something. Let's see. Point B was 3, 4. 3, 4. So what did we do with x? We said 3 units to the left, so that becomes D. That becomes point E. So if you take this 3 units to the left, you're subtracting 3 from there, so that becomes a 0. If you take the y coordinate 1 unit down, that becomes a 3. So E is 0, 3. So that's still consistent with this. And let's just make sure that the F works. So C was 1, 3. If we take 3 away, right, we shifted to the left by 3, so that's taking the 3 away from the x coordinate, so that's minus 2. And then if you're shifting the y coordinate down 1, that's taking 1 from it, so that's 2. So F is minus 2, 2. And so D was definitely the answer. Problem 79. If triangle ABC is rotated 180 degrees about the origin, what are the coordinates of A prime? Okay, so we're going to rotate this thing 180 degrees. And essentially, I mean, we could worry about all the coordinates, but they just want to know where A prime is. So this is going to have, so wherever A sits after we've rotated it, right? So let's think about it a little bit. Let's think about it a little bit. When we've rotated the C, this is going to be the new C. It's going to be right there. And then the new A, so let's see, the B is going to be, when you rotate it, I just want to make sure I'm doing this right. This is almost like this is a visualization problem. If you go 4, no, if you go, this is 4 to the right and up 3, right? So if you were to rotate it around, if you were to rotate, let's say this little arrow I drew with the 4, if I were to rotate that 180 degrees, I just want to make sure I do it right, then that's going to be 4 this way, right? That's going to be 1, 2, 3. It's going to be 4 this way. So you're going to be at that point. And then you're going to go, instead of 3 up, you're going to go 3 down. So it's going to go 3 down. 3 down. So that's where A prime is going to be, right at that point. Right there. And that's the point minus 5, comma, minus 4. That's minus 5, comma, minus 4. And that's our answer. But let's figure out all of the other points. So B, you go up 2, to the right, up 3 and to the right 2. So then you would go from the new C, you would go, let me make sure, right, about the origin, right. So the new C, I'm just trying to make sure I'm right. The new C would go, the new B, you'd go 3 down to the left. Okay, it'd be there. So that's the new B, right. And so that looks right. That's what the triangle is going to look like. This is B prime, this is A prime, this is C prime. Right? This is the new triangle when you rotate it 180 degrees. That was a challenging visualization problem, but the key thing is just to keep visualizing going around 180 degrees. So -5, comma -4, that's choice A for A prime. Problem 80. Problem 80. Let me switch to a better color. Trapezoid ABCD below is to be translated to trapezoid A prime, B prime, C prime, D prime by the following motion rule. Okay? What will be the coordinates of vertex C prime? Okay, so that's all we have to worry about. We're at C and we're going to translate it to some C prime. What are the coordinates of C? C is x is equal to 5 and y is equal to 1. So what's C prime going to be equal to? C prime, we'll just use this mapping rule. You add 3 to the x, so it's going to be 8. And you subtract 4 from the y. So 8, 1 minus 4 is -3. 8 minus 3. And that's choice D. And we're all done. We're all done with the entire California Standards Geometry test. And frankly, I started off grumbling a little bit because I thought they were getting a little bit too obsessed with the terminology. But overall, I think this was a pretty good test. And if you understood every problem on this exam, I think you know your geometry pretty well. Anyway, see you in the next video. Although this is the last in this geometry series.